Micromine Mining and Geological Information System is a modular software product. With the help of this program, you can solve a wide range of tasks related to the work of various departments of mining companies, as well as consulting and exploration companies. The tasks performed in a mining and geological information system include the creation of geological model of the deposit, which can later be used to estimate reserves, design quarries, dumps, roads, underground mine workings, calculate mining volumes, plan open and underground mining, design of drilling and blasting operation, and etc. The program consists of 11 modules in which the solutions functional of the surveyed problems is incorporated. Modular structure of the program allows you to customize the workplace for a particular specialist. Thus, there is no need for the company to buy the functions that it does not want to use. Also, the modularity helps to avoid importing and exporting data between different programs. A specialist from one department can simply transfer data to a specialist from another department without unnecessary manipulation with them. Let's consider the sequence of deposit modeling in a GIS on the example of the gold ore deposit in the Micromine program. The first stage is the creation of the geological model of the deposit. For a start, it is necessary to prepare the data based on which the model will be built. As Micromine supports many different formats for importing, it is possible to transfer the data created in other programs. For example, Microsoft Excel. If the data is not in electronic form, they can be filled directly in a software environment. The main files for building the model are an assay file, which must contain the assay coordinates of each drill hole, its unique identifier, as well as the depth. In addition, it can have any additional information that may be needed for the further work. For example, the year of drilling, the number of the exploration line to which the drill hole belongs, and so on. A survey file, which contains the identifier of each drill hole, the depth of the measurement, as well as the angle and azimuth to which the drill hole trajectory deviates. The presence of such file allows to design the ore body or bank more accurately later. A testing file, which refers to the interval file and is a set of intervals which the marks form from and to for each drill hole. Moreover, each interval has a set of different characteristics depending on the type of deposit, for example, information on the content of the useful component or the quality of the coal. A lithology file, which is also an interval file, but where each interval has a certain lithological code that characterizes a particular interval from the geological point of view, allowing to determine what type of rock is at a given depth. Based on these files, a database is created. However, frequently mistakes are made while working with the data, so it is necessary to check the database. There are several stages for validation. One of them is a test using this program's functionality. It allows to identify such errors as overlapping intervals, missing intervals, intervals below the total depth of the drill hole, and so on. If such errors are detected, it is necessary to return to the original documentation and fix them. Another stage is a visual check. It is necessary to display all the data in a software environment and compare the screen data with the ones in real life. For example, check the direction of drill holes, their position in space, and so on. After the database has been checked for errors, it can be used for further work. The next step is to calculate the ore intervals. To accomplish this task, there is a certain function called according to the content of the State Commission for calculating reserves. The algorithm that it contains allows us to identify ore intervals satisfying all the requirements of the State Commission for calculating reserves for this process. However, to start the process, it is necessary to set the conditions, namely cutoff grades, top cut grades, the minimum thickness of the ore interval, the maximum thickness of the waste interlayer. It is possible to supply the variables in terms of economy and technology of mine development. Also, they can be taken in terms of geology, but it's necessary to analyze the input data, namely testing file. To do this, it is possible to construct a histogram, cumulative frequency graph, and a graph of probability. On the basis of the ore intervals file, the ore outlines are constructed. This process is rather complicated and time-consuming and demands knowledge from a specialist in the field of geology, subsurface geometry, and understanding the mine geology. Therefore, in addition to the file of ore intervals, a lithology file is also used. The correctness of the ore body delineation directly affects on the amount of reserves that will be put on the balance sheet. Next, a wireframe model of an ore body is constructed using the method of triangulation, which is based on the Delaunay triangulation method. In simpler terms, the points of one outline are connected to points of another outline in the form of triangles. Thus, this framework is essentially a set of triangles. The result of this procedure is a closed frame of the ore body with a certain volume. These frames are called solids in Micromine software. In addition to building the ore bodies, the construction of a topographic surface is also a necessary stage. As a rule, to construct the topographic surface, the survey data is used provided by a surveyor. Micromine contains a functional that allows improving the survey data directly from the surveying devices without the need to use intermediate formats. The next step is building a block model. The block model is a set of blocks. Each block has the coordinates of the center and the dimensions along the axis as well. Two types of block models exist: ore block model and full block model. The ore model is built directly within the ore body framework, whereas the complete model is addition to the ore also includes blocks of waste. After the model is created, it runs through the estimation process, which means that each block is assigned with the content of a useful content. Many methods in interpolated block model are available: the inverse distance method, single region and universal region, indicative, multi-indicator region, and median region. When evaluating a block model, it is also possible to divide the reserves into categories in accordance with the requirements of the State Commission for the Calculation of Reserves or international standards. For example, the Joint Ore Reserves Committee. A fully evaluated block model can be used to obtain reserve reports. If it's planned to develop the deposit by open pit mining, it is necessary to optimize the open pit before creating a pit project in order to obtain the optimal pit outline. The optimal pit outline is the most profitable area for mining from the economical point of view. The optimization process is based on a large Grossman algorithm, which in turn is based on graph theory. The open pit optimizer is the part of a program, so operation with it does not require data import or export to other programs. Input data for this process is a block model, which can be either ore or full, as well as the cost parameters such as cost of mining, the cost of ore processing, the cost of useful component sale, and so on. In addition to obtaining a loop for a given indicator, it is possible to obtain additional contours, taking into account changes in the final product prices, for cases when the increase or decrease in the value is predicted over time. This set of contours can be used for further analysis, already considering the career performance as well as all capital and regular costs and discount rates. Pit design is carried out on the basis of the optimal contour. When designing the pit to determine the parameters of the quarry elements, the physical and mechanical properties of the rocks and the morphology of the ore body are taken into account. The first stage is the contour of the quarry, which is a set of lines corresponding to certain elements of the quarry. In the future, these lines are transformed into the digital model of the pit. The creation of the pit framework allows to obtain a report on reserves using a block model directly within the quarry. Design of drilling and blasting operation is carried out on the basis of a pit project. In addition, the quarry surface can be used for mine development planning, taking into account all technical and technological features.